Hello and welcome everyone. Thank you for joining us for today's expert webinar titled Understanding the Basics of Microservices. I am Ria from SpringPeople. We are India's largest enterprise training providers and I will be your moderator for today's session. In today's session, we have Pallavi Prasad with us, who is an accomplished corporate trainer with a passion for bridging the gap between technology and business. With over 500 successful training sessions delivered, she has earned recognition as a trusted expert in her field. Pallavi is laser-focused expertise in C with data structures, OOPS concepts, C++, VC++, multi-threading, Core Java, JEE, Spring, Hibernate, Unix, Linux, shell scripting, .NET Framework 3.5, CVB.NET, ASP.NET, ADO.NET, JavaScript, PhoneGap, Cordova, RPA, Automation Anywhere, UiPath, AngularJS, to name a few. Pallavi Prasad's commitment to delivering timely and effective training has consistently added value to organizations, ensuring that participants are well equipped to apply their knowledge effectively in real-world settings. In today's webinar, Pallavi Prasad will let us know about understanding microservices, the advantages and disadvantages of microservices, building RESTful microservices, service registry. To all the participants, you can mention your questions in the chat box and it will be answered at the end of the session. Now, without further ado, let's start today's session. I would like to invite Mrs. Pallavi Prasad to start the session. Over to you, Pallavi.
Thank you, Ria. Good evening, everybody. My name is Pallavi Prasad, as Ria has already introduced me. So let's start understanding what microservices are. I'm fairly certain that all of you have probably heard of the term microservices. So what is it basically? How do you work with it? And what are the advantages of it, the disadvantages of it? How do you write your web services for when you're working with microservices? How do you get to communicate between these microservices? We'll be covering a bit about all of them on a broad perspective, more like a bird's eye view of everything. So coming to what microservices are, one of the first things that I would like to take an example of is the Netflix streaming platform that we have. So when you're working or when you watch Netflix, you would notice that there are various languages that are delivered to us over, the latency of it's rather quick when you want to watch a particular movie in a particular language. The delivery of that particular movie to you is rather fast. It doesn't take a lot of time. The latency is very low. How is this even possible? Another thing is there are a huge range of movies that are available to you on Netflix. So how does this work? I mean, what is the trick behind these streaming platforms that we have? I've just taken Netflix as an example, but many of the other streaming platforms have also switched over or are working with microservices. So how is this possible? Is by breaking up the various parts of an entire platform into smaller services. So just on an overview, let us say that I want to watch something in Korean, French, English, Hindi. So whatever I want, let us assume there is one service that is delivering that particular language's movies to me. Now that is what microservices is. It is a set of small services that are going to communicate with each other and deliver what it is that you want. So the agenda for today is to understand what microservices are, the advantages and disadvantages of microservices, a quick overview of the services architecture, how to build microservices and registering microservices. Now, the last two that we have is mainly going to be a demo. I would like to try to show you how it works. So let's have a look at what microservices are first. So as I already told you, these are small independent services which will communicate with each other. So it doesn't have to be that they are written in the same language. It is okay that they may be written in multiple languages for you. But the way you write the services is ensuring that they communicate with each other. One major advantage of working with a microservice is that they are independent. That means they are loosely coupled. So when you are going to be working with one service or making adjustments or scaling up one service, you don't have to worry about it affecting everything else that is also running alongside it, which is one of the major advantages that microservices gives us over and above what it is that the monolithic architecture gives us. So earlier what used to happen was we used to write monolithic code. Nothing wrong with monolithic code when you're working with small sized projects. You don't have to worry too much about information coming from varied sources. The You can say there is only one source or maybe a couple of sources of information that are coming into the project and going out of the project. So the number of users for the project is also on a lower end. It is not like there are a lot of people accessing it or something. So you don't need to worry too much about network traffic. I mean, not too much. It's possible to manage without too many overheads. For such projects, having a monolithic architecture is absolutely fantastic. So what do we mean by a monolithic architecture is that everything is interdependent. That means all my services are tightly coupled. So even if one service is going to be updated or crashes, it will cascade into all my services. So that is a monolithic architecture. Everything goes one along with each other, hand in hand, basically. So, when you have large projects which need to ensure, like the Netflix, the OTT platform that I just now told you. So when you have platforms like that which require constant flow of information, especially these streaming platforms, as you know, such situations we do prefer working with microservices as opposed to having a monolithic architecture. So what are the advantages of microservices? The advantages that we have is that it is possible for you to be able to upgrade each particular microservice independently without having to upgrade the entire application. In fact, recently I was having a look at a particular tutorial for Node.js, in fact, and the uh, person who was talking about Node.js spoke about it being maintained by Google, or rather the V8 engine on which Node.js runs being maintained by Google. So one of the problems there is that because Node.js happens to depend on the V8 engine, any updates to V8 engine also require Node.js to be updated. Now that kind of creates problems, because if the technology does not go hand in hand with the engine that is running that technology, then there is a complete mismatch. You can't make use of that particular tech. So that kind of a situation is avoided when you work with microservices. I'm not saying that Node.js is an example of a monolithic architecture. It is just a simple example to tell you how a tight coupling basically works. So these microservices are also independently deployable. So I can deploy them one after another. I don't have to make sure that my entire application gets deployed at the same time. Easier to code, or should I say develop, easier to scale, easier to deploy, and they have a faster release cycle because you're not writing a large amount of code, you're writing and updating only that service that you would like to handle. Everything that comes with advantages comes with disadvantages as well. So you have anything at all that has an advantage, there is a flip side to it. And the disadvantages of microservices are that there could be a problem with communication. One problem that I have personally faced is database connectivity. All of a sudden, my microservice will crash. That particular service will not connect to the database. No idea why it happens, but it does happen. Then when one more thing is, the larger the application, the more number of services. More number of services, it becomes a little bit unmanageable, or should I say difficult to handle them. You want to ensure that everything is running perfectly, so you need to keep on your toes to make sure that all the services are running the way they are supposed to. So the number of services increases, the time you spend figuring out and ensuring everything is running on top, on the way it is supposed to run, that is a time consuming process. One more thing is that you have to also worry about network latency. You have to worry about load balancing because you're working with microservices and you don't know when the services are going to be receiving high traffic. You have no clue. I mean, you can't predict. So you have to have the necessary fail safes in place to ensure that there is a proper load balancing, that whatever traffic is coming in is distributed across multiple servers, so as to ensure that your microservices don't freeze somewhere when it is absolutely important. Another thing that you need to worry about when you worry about microservices is ensuring that all your services are running. Because one of the issues is that if one service crashes, it could possibly affect one of the other services or many other services with which it is communicating, which could create what we call as a cascade effect. So to avoid this cascade effect, you have to make sure that you have the necessary fail safes in place. For example, you want to ensure that if a particular service fails, you have some kind of data that is actually sent without crashing the others which are communicating with this particular service. So we do have fallbacks for everything. We do write fallbacks for everything to ensure that all our services, even if something fails, you have some information that is being sent across instead of error messages, so that you receive that particular message, you know that yes, there's a problem, you come back and fix it. Another thing about microservices is that the architecture that microservices follow is a lot more complex than a monolithic architecture. Monitoring microservices is definitely a huge challenge because you don't know where a particular microservice has crashed or why it has crashed. So backtracking and debugging can be a lengthy process in some cases. Again, more number of services, more issues to face. So what do we do then, and how is this particular microservices architecture created? Now, your microservices architecture is basically made up of some key components, what we call as key components. One of the first components that you have are the services themselves. You call them as your core services, basically. So what these are the services themselves, the REST APIs that you write. Now they are called as your core services. Along with this, you also have what we call as a service registry. So a service registry is basically a database inside which you're going to register your microservices. Now, the reason why we do that is so that all the services are aware of the other services that are there in the system. So when you register, you're informing the other services of your availability or of your existence, basically. So inside this database, you basically set up your locations, you set up the the IP addresses. The locations, I mean, is the IP addresses. And this service registry basically allows for the communication or for the discovery of services so that they can communicate with each other. A simple example of a microservices architecture. I haven't put too much here. This is something I um, thought would be easy to understand. So you can see that we have three services. One is an account service, the other is an inventory service, and the third one is a shipping service. I have three databases in the backend. One is an account DB, inventory DB, and shipping DB. Now these three services have their own explicit databases that they are connected to, that they are communicating with. Now I have another service that is talking to these three services through the APIs that we have written. Now, whatever is the web application that we have written, that is going to talk to the three services that we have. You can communicate through an API gateway. So what's an API gateway then? It's considered as a single entry point for all these incoming services requests that we are going to be working with. So all your requests, all your microservices, now they are going to have to go through the API gateway so that they can communicate with the outer world and vice versa. So it takes care of all the routing requests, ensures that the necessary routing goes to that particular service. It handles authentication. It also takes care of ensuring that if some service is down, then appropriate messages are communicated across. So all of that goes into your API gateway. Now, along with this, you also have your service registry. It's not up here on the this one architecture. I've just mentioned them here. You also have your what we call as the service discovery and your load balancing. So load balancing is basically when we have multiple service instances that are running and you want to be able to ensure that the network traffic is equally distributed along the various instances that are running based on load and based on availability. You don't want to freeze up the paths to a single service instance. So we usually run multiple service instances and ensure that the information is, or rather the traffic is equally distributed across the services that are running based on whichever one is available at present. Then you have CI/CD, which is another component of a microservices architecture. So I want to be able to make sure that the development and the deployment process of microservices is as smooth as possible. So we usually use tools like Jenkins or Circle CI or any of the various other tools that are available to automate this particular process of building, testing, and deploying your microservices. Whenever you're working with microservices, monitoring the microservices becomes a really, really important task because you want to ensure that your microservices are running perfectly, and any issues you want to be able to log those issues. So monitoring and logging are definitely very necessary to track the health. For this, we use for monitoring, we usually use the actuator as a health monitor. And there are various tools that are available that we use for logging. You have your log4j, slf4j. There are a lot of logging tools that are available as well, which allow you to log whatever issues or whatever work that your microservices are actually doing. Now, I have a simple setup already working and ready. So let's get into looking at how to build a RESTful microservice. Now, what is a RESTful microservice? Basically, is when you write your REST APIs inside a microservice, you call it as a RESTful microservice. Now, the thing is that I'm not going to write it. I have the demo ready. So I will just take you through what is supposed to be written. So just give me 1 minute. Yeah. So let me just close the unnecessary ones. I'm stopping all my services. Okay. So I have, I think, I don't know whether it's visible. Just give me a minute. Yeah. Now I think much better. So as you can see, I have already written my services. I'm closing everything that is there. It's a pretty simple web services that I have written, literally very simple ones. I have 3 services. One is a department service, the other one is an employee service, and the third one is organization service. Now, these 3 services have their own respective backends in terms of 3 specific databases. I have one database for departments, I have one for employees, and I have one for organization as well. So let me just open that as well. Yeah. So I already have, as I said, 3 of them. This is organization, this is employees, and this is departments. So 3 services with 3 backends already written in. Now getting into one of the services, you look at, I've started off with the employee service. So in my application properties, I am connecting to a database using, I have a MySQL database, so I'm connecting to it with the necessary password and the username. Then I also have my necessary specifications up here. One more thing is that I've already added the Eureka server as well. So one of the things that we use when we want to discover a particular or register a particular services, we make use of the Eureka server. So when you get into actually working with the Eureka server, I've added a dependency for my Eureka server inside a specific project separately. Now this is going to start running first. The other services will automatically connect to the Eureka service and it will register and show it to me. Now, how do I write my REST services? So the first thing that we do is we usually write application properties. Now the application properties that I've written here are straightforward. We also use YAML to write these application properties. I haven't written it in YAML. I'm writing it in a very straightforward dot properties file. You will find people who are using YAML as well for application properties, which is a comfort level basically to each their own. I'm comfortable with this. Now, as I said, I have 3 services. The first one is a department service. So if you get into the department service, if you open up application properties again, you will notice that there is a specific DB associated with it. And there is a different port for each of the services that I have. So Eureka works on a different port. It works on 8761. Then I have department service running on 8084. Then I have another service, the employee service running on 8082. Now, how do we write the RESTful services? So you're all familiar with what are RESTful web services. So when we write REST APIs, that is essentially how we work with our RESTful web services. So let me just quickly open up my services that I have written here. So I have my entity class that I have already written. This is a simple entity class. I'm using Lombok here to work with it. So when you're working with Lombok, obviously you are going to be making use of the necessary annotations to set it up. So I've written my entity class here. Then I also have my necessary controllers, my services, and my repositories, as well as my mapper classes. Everything is already been written here. So now I have my services. This is the department service. Another one is my employee service. I have the same setup here as well. The difference is that I want to ensure that these services communicate between each other. So my communication is from employee to the department. So that's the reason why I have written a client service here, API client. This one is using a communication tool called as OpenFeign. So I'm using OpenFeign here for the communication process only. Now you can communicate between the various services in three ways specifically. One is using a REST template, the other one is using OpenFeign, the third one is using a web client. So I've written a web client as well here just to show how it looks. So this is a very simple way of communicating. I'm just retrieving the data from the department service using my API. Now let's have a look at the config for the web client as well. This is for the web client. So I want to be able to work with the web client also, means I use web client. Otherwise, we can use the API client that I have already written. So where am I working with these is in my implementation class. So when you get into your service implementation class, here we have written the necessary setup for us to work with the various clients to make sure that we retrieve the data from the database and show the content onto the database. Of course, I have a circuit breaker also available here in case of my services not communicating with each other or one of them crashing. I want to have a fallback. So I have set up a fallback as well. So you can check this is the default department is my fallback method that I have essentially written. So this is the one for my employee service. There is one more I have written for the organization service. Okay, so how does the registration work? Now, here in all the three services, the department service, the employee service, and the organization service, in the form.xml, we add a particular dependency called as the Eureka client dependency. Now, this Eureka client dependency is the one that is going to ensure that the server can connect to this particular client or this particular client can register on our Eureka server. So let's see. This is basically how you're going to write your REST services. Now, shortage of time, so I cannot write a complete project here, but this is the basic, this is one of the most basic REST services that are there. It's not very complicated, one of the most basic ones that we have. Now let's have a look at how we can work with these. Now, once you have your service registry server available, we usually start off our registry server first. So I'm going to start my server. And the server is running. So my server is up, it's working. Now, if I go to, you can check, this is my Eureka server. At present, it says that there are no instances available. So there is only one available, which is my localhost/Eureka. This is the only one that is available to me. The server is up and running. Now we have already written various clients that we have available. We have 3 microservices that we have written, which are supposed to be available now. So now what we are going to be doing is we are going to start running these services one after another. As I said, these services could possibly crash as well. So we do write the necessary fallback methods in case the services don't come up or there is some issue with the communication. So I'm going to start off with my employee service first. So let's start with the employee service. Let us see if it will run or if it will decide not to run. It says that there is no suitable URL available. I think there is an issue with the database connectivity somewhere. Let me cross check. I'm stopping it. So let's cross check and try to solve that particular problem. Because as far as I remember, I've written it correctly. So there must be something else that is being a problem. So what do I do in this particular situation, and how am I going to ensure that I write the necessary data available? How do I set it up? So I can write the whole thing again, but again, as I said, time consumption. So let me do one thing. Let me check to see if my MySQL is there and available. Yeah, I do have my MySQL. This is there, it's the connector is there, which means that there is some other issue that is occurring. Now you can see the problem here. Everything looks good, there is no issue, but my service is not running. So how do I track the problem here? What do I do with in a situation like this? So that is one of the problems that we usually face when we are working with microservices. This is a simple enough microservice. I mean, it's one of the most basic microservices that we have available with us, but still you can see that this one is not working the way it is supposed to. It's not connecting. Now if I go to the organization one, I have stopped my service, by the way. So if I go to my pom.xml here, you will notice that it's absolutely the same. I haven't made any many changes here, and the application properties of my organization service is also similar. Again, not much of a change. This is all I've written there as well as here. So, but in my this one, what do you say? In my employee service, that particular problem is occurring. It is not able to connect to the database. So this is one of the issues that we face. Usually what we do is we just rewrite the entire properties setup. So let me do one thing. Let me try once more. Okay, let me just try it once more. Let me see if I can start off with my department service and whether it will still give me the same issue once more with the department service as well. Or will it also crash? Let's just check. Okay, it seems to have started off, hopefully. Yes. So now let me go back and check and see if it's actually registered. Refresh this. You can notice that the department service is actually registered. So I think I know what could be the possible problem. So I'll just retype this particular line. Don't ask me why, I have no clue, but it works sometimes. So I just usually delete it and just retype that one line. Sometimes there is, I don't know, some issue internally. So I think it is employee underscore DB. And now let's start off with the employee service. So we have started by registering the service. Sorry, my mistake. So I've started off the second service as well. So my first service is already registered. Now I'm starting off the second service as well. And it says there is a problem with the Fine client. Okay. So you can see everything is working fine, but sometimes these kinds of unexpected problems turns up. It's saying that there is a small problem. It's not able to connect to the Fane client. So that's the issue that it is giving me. I need to figure out what could be the problem for this, for load balancing. So did this, okay, let me check, let me fix it. Now the third one is my organization service. Let me just run this. I'll fix that's a small issue somewhere. I think one of my, this one was gone anyway. Now the organization service is also started up. Now let's, if you go back and have a look at your Eureka, you should see the services have been registered. Now both of these services have been registered. They should be available to us when you are going to run them through your Postman. Now let's see if I can get them to work through my Postman. So this is the department details, and you can see the port number is different. Let me see whether I have the, okay. So the reason why this is coming up is because I had an API gateway that I have removed. So that's the reason why it is giving me an issue. So I think 8084 is the one that we have to work with. Now let me just go back and cross check to see what is the controller that I have written here. So it says /API/departments. So I want to be able to map it to a particular code. So let's see. And it is retrieving the data for me. Now I can also get it to retrieve the necessary content, except that my employee API is not working. Should I say the REST API has decided to crash on me. So I have to fix that small issue, and it will take me a little time. So that's the reason why I am not going to fix it now, but I know what the problem is. And the problem is that one particular service has been removed. So that's the reason why, or one particular dependency has been removed. So I have to add the dependency, and that's all is actually necessary for me to fix that particular problem where load balancing is concerned. That is the issue that has occurred. So yeah, we can fix that by adding the necessary load balancers and everything. I will be adding that later. So this concludes your microservices, and we have quickly had a look at some of the most basic content. There are lots more. There is a lot more to microservices than what I have just now shown you. This, you can say, is just the tip of the entire iceberg of microservices. It's a very, very fascinating architecture and a very useful one, even with all its drawbacks as well. So any questions, please? No, actually, I don't think all products have moved to our microservices. you will find that some organizations, okay, without mentioning any names, one of the organizations that I trained with had a web application that they were using as an internal application only within their organization. It wasn't a very huge one. I think the maximum number of people who are accessing it were probably about 500 or something. So relatively small comparatively. So in that situation, they had working with a monolithic architecture. In fact, that entire application was built using the mean stack. I know MongoDB and Express and Node and Angular. So that seemed to be quite a. You can take that as an example of a monolithic architecture. Again, it's not prevalent everywhere, but yes, there are still companies which use monolithic architecture, not for big projects. Again, I mean it, not for big projects. Okay, the second question I'm getting is from Mr. Pranav. Yeah, best way to test REST APIs. Personally, I like Postman a lot, but even better than Postman, I would say, would be Swagger, because Swagger comes with its own set of documentations and everything. So you can, create documentations for the APIs that you write as well, which seems to be, as far as I think, that could be one of the, plus points for Swagger. But just for testing your REST APIs and checking to see if they work or not, I think Postman is a fairly decent tool for that. Then I have another question from Mr. Abhishek. How do microservices communicate with each other? Okay. So when you want to talk about microservices communication, they usually communicate using tools like REST. Okay. Instead of me telling you about it, let me try to explain it to you in an easier manner. Yeah. So we do have tools which facilitate this communication, but what actually happens when they communicate is basically it is going to be more of a response and a request kind of a thing. When we work with when we write REST APIs, when we write our controllers, we basically are going to use a web API to run our HTTP methods, right? A get, a put, a post, and everything. So here also the same thing happens. I mean, the same kind of communication happens. It is more of one service accessing the content of another service. So when you talk about microservices communication, there are two ways that we communicate between microservices. One we call as synchronous communication. The other one we call as asynchronous communication. So in case of synchronous communication, one service will send a request to another service and wait for a response, basically. I think you're aware of that. So let us say that microservice one is asking, or employee service is asking for some information from department service. So employee service does not respond back until the department service comes back. So that's basically your synchronous communication. In asynchronous communication, the wait time is not there. So each, when one service talks to another service, it will send the request and it will not wait for a response before it is sending the next request. So that is basically asynchronous communication. So when we are working with microservices, we usually prefer asynchronous and not synchronous communication. So to facilitate this, we use tools like OpenFrain, where you provide the service that it is supposed to connect to. So just 1 second, let me go back to the code. I'm not sure whether my screen is still visible, but let me just open the employee service. Let me show you the API client that has been written. So if you notice here, I'm passing it a particular value. I use a Fain client. So the Fain client takes care of two things for me. One is it takes care of communicating with that particular service that I have mentioned. I have told it to communicate to one service. That means this is going to act as a client and the other service will act as a server for a small period of time. But okay, so basically I just wanted to tell you that when you are when there are two services communicating, we use your fine client. One of the things about fine client is it works as a load balancer as well as a communication tool. I hope that answers your question. And yes, microservices do use message queues. We call them as message buses basically. So what these message buses what these message buses do is they, we use Kafka or RabbitMQ, etc. that we are going to be working with. And that's what the queues are that work with. And as for what protocols generally are used in between microservices communication, most of the time it is HTTPS. In this case, the example that I showed you, it's HTTP because they are all on my laptop only. But in a real-time situation, it is always HTTPS. We want to be able to make sure that the communication is secure. So yes, we do use HTTPS protocols basically, and HTTP methods that we have. Is microservices effective only in web applications? Yeah, yes, microservices are usually for web applications. Ideal example, as I told you, is streaming platforms. But in embedded or industrial automation applications, I haven't come across microservices there. But let me just maybe have a look at that and get back to you. How can we handle the cross reference of DB? Okay, so the DBs we do not cross reference. Each microservice will connect to its specific database only. It is not going to comment with the it's not going to connect with the database of another service. So any communication that we do goes through the services only. So any kind of cross referencing you do, we write DTOs and we write mappers so that we can, and we write filters so that we can retrieve the data from multiple databases through multiple services. And based on some filtering, we can show the information available. Right. Can you briefly explain event-driven? Give me 1 minute, please. So you want to understand about event-driven architecture. Okay. So when you're going to be working with event-driven architecture, it is basically when something happens in response to an event. So one of the best examples that we have is when we work with Amazon, we have something called Lambda on AWS. So you kick in that Lambda or you trigger the Lambda function when you want to, when something happens. For example, when I'm pushing something into a, let us say an S3 bucket. This is the example that I'm using, that's all. So when I'm pushing something into an S3 bucket, if let us say the data that I've pushed into an S3 bucket is of a particular size, then I want a Lambda function to trigger and move that particular content, or tag that particular content, or change its permissions, whatever. So I want to set up some kind of a protocol for making sure that once a particular item meets a criteria, something should happen. That in essence is what is a event driven architecture. I mean, that's the briefest example that I can think of when we work with event driven architecture, but there is more about event driven architecture. Let me see if I can give you a very brief example of it. Okay, let's take one more example of an event driven architecture. So even, okay, you go to, let us say you go to a bank, you want to withdraw some amount. So you push your ATM card into the ATM machine. Once you push your ATM card into the machine detects the card and comes up with a screen for you. Now that is in essence what is an event driven setup. So that's an event basically that is happening. So when you are going to be working with this particular architecture, What are the components that are available within the architecture? We have three particular components inside a event-driven architecture. You have a producer, you have a consumer, and you have a broker. Now, the broker is essentially optional. You can have only a consumer and a producer as well. But if you want to, you can have a broker also. So what happens is that a producer is going to be talking to the database or the data warehouse or whatever, where the events are going to be stored or the transactions are going to be stored. The consumer is somebody who is going to be accessing or generating those particular events for you. The broker is usually a middleman between the consumer and the producer. That's in essence how it works, or rather what happens. So if you want an example, let me think. Okay, this is an example that I found online. So I think that's one would be ideal. Let us say that I am working, I own a huge string of shops, let us say clothes basically. So what I need is I want to be able to collect the data from across all the shops that I have, all the stores that I have, and I need to generate a report of it. I also want to be able to watch out for credit card frauds or for any kind of fraudulent behavior. So I need to watch out for that as well. So how am I going to do that is I will send the data that I have through the event-driven architecture based on some criteria that I set up. Accordingly, the architecture will ensure that the information is handled the way it is supposed to, and I get the output in the form of maybe a report or any of that sort. Here, the producer is the one who is going to be storing the data that is going to be coming from multiple sources. The broker is the one who is going to be first handling the data and then sending it to the producer. The consumer sends, that is the me who is actually collected the data, raw data, will send it to the broker who will process it and then send it to the producer. Event-driven architecture in as brief a way as I can. Okay, so I have another question here. Whenever I read about microservices, I see only Java examples. Yeah, because that is one of the most easiest ways in which you can write your microservices. But that it is not, microservices are not specific to any language. I also showed you a Java example, I know, but you can write microservices in Python. You can write it in C#. You can write it in any language that supports REST APIs. So any language, any tech that supports REST APIs, you can write your microservices in, because your microservices essentially depend on these web APIs that you are going to be working with. So you can pick based on the support for REST APIs that you have. So yeah, I have seen people coding in Python and in C# for microservices as well. You don't have to worry in case of microservices about the language the service is written in, because it's going to only connect to the IP addresses, the APIs. That's all it does. So each service will talk to the API on which is running on a particular port and a particular IP address. So you don't have to worry about the language in which that particular microservice is written. In which situation microservices can use monolithic database or separate database, whenever you write a microservice, always we use one database per microservice. We don't use a single database for all our services. Then the point of writing a microservice is lost if you have only one database. If you notice in the code that I showed you, there are 3 explicit databases that I have. one for employees, one for department, and one for organization. You will find people writing it in that particular way only when you work with microservices. There is no other way to write them. Or rather, there shouldn't be any other way to write. So I hope that answered all your questions. Anybody else has any questions? Please do ask.
Okay, thank you, Pallavi, and thank you, everyone. We appreciate you being here. We shall be sending out the webinar recording to all you participants soon. I request you to kindly provide feedback before signing off, which will help us improve the quality of our future events. Thanks again for joining us today. Signing off on behalf of Team Spring People. Hope to see you again for our next expert webinar. Thank you.